problem number 8. Two blocks of wood with W and thickness T are glued together along the joint inclined at the angle theta as shown in the figure. Using the free body diagram concept in the figure, show that the shearing stress on the glued joint is equal to P sine 2 theta over 2A, where A is the cross-sectional area. So here in the problem, it says that A is the cross-sectional area, and the cross-sectional area is this. So it is the product of the width and the thickness. So it's WT. Now, if we are going to compute for the shear area, yung shear area natin, ito yung rectangle na to with the blue dots. Since it is inclined, itong part na to na naka-inclined ay tatawagin nating diagonal. Now, if we are going to compute for the diagonal, kung ito yung view niya dito sa side na to, then this is the angle theta. So kung titingnan natin dito, itong part na to, this is the width of the block and this is the diagonal. Now, if we're going to compute for the relationship between the W and the diagonal, we could say that since this is the opposite of the hypotenuse, this is the sine of theta is equal to opposite W over the hypotenuse, which is the diagonal. Now, diagonal is just equal to W over sine of theta. So we have the shear area, it is just equal to the diagonal multiplied by the thickness. So we have here thickness multiplied by the diagonal, but diagonal is W over sine theta. So this would be TW over sine of theta. So from here, the cross-sectional area is just equal to the product of the width and the thickness. So here, the TW would be the cross-sectional area. So we could say that this is just equal to A over sine of theta. So kung gagawa tayo ng free body diagram, and this is the force P. Now, if the force P will be acting on the inclined surface, then this P here would create a component. So if this is P, and we denote the component parallel to the inclined surface as the shear force, and N is the component normal to the inclined surface. If this is angle theta, then this is also angle theta, which wherein this part here is also angle theta, since this angle is equal to this angle. Now, if we are going to express the relationship of the shear force to the force P, we could say that, as you can see here, the shear force V is adjacent of the angle theta and P is the hypotenuse. So we have K, and it is cosine of theta is equal to adjacent V over hypotenuse P. So we could say that V is equal to P cosine theta. Now, from the idea of the shear stress, we have shear stress is equal to shear force over the shear area. So we have the shear stress is equal to V, but V is equal to P cosine theta. So we have here P cosine theta over V, which is equal to A over sine theta. So this is A over sine theta. So simplifying further, and we have the shear stress is equal to P sine theta cosine theta over the area. since we're just going to take the reciprocal of this and proceed to multiplication. So from the idea of trigonometric identities, we know that sine 2 theta is equal to 2 sine theta cosine theta. So meaning sine 2 theta over 2 is equal to sine theta cosine theta. So pwede natin i-express si sine theta cosine theta as sine 2 theta over 2. So we would have shear stress is equal to P sine 2 theta over 2 multiplied by the area. And this is our answer.